Hi. Welcome to Code and Coffee on this sunny day. I'm actually surprised there are this many of you who decided to actually stay away from that. I was very tempted, but here we are. Welcome to Code and Coffee. Code and Coffee is our community stage and community meetup where we do usually two things. One thing is we host talks where anyone can speak, anyone being anyone of any skill level with an interest or experience in anything related to technology. And the second thing we do is we provide a safe space where everyone can come and meet other people who work doing similar things to what they do, anything within the realm, again, of technology. So welcome. If this is your first time here, actually, I usually do this, but is this your first time here? If it is, hands up. Oh, fairly new crowd. That's fairly cool. Welcome. So because there are this many of you who are here for the first time, and I do this anyway, even if there wasn't, this is an introduction. Code and Coffee being what it is, a community stage, we have code of conduct. So that's very important to us. And you should read it because it's online and fairly accessible. But in summary, be kind to everyone here. And everyone will get along just fine. And we do enforce that. So, yeah. Steve, Stu, and I, we are the organizers who are here today. And we're available at any time if you want to ask us anything about the meetup or if you want to talk. Because, as I said before, anyone can talk. So if you're interested in giving a speech, come talk to one of us. But today we have two talks for you. The first one, before it starts, I should give you a quick introduction, is going to be about simple web services and Authbind and Python. And that's going to be given to us by Clemens. So, where's Clemens? Hey, Clemens. Cool. Can you please welcome Clemens up here? While Clemens is setting up, I will also be taking questions. There will be a question period like right after where you will be given a mic and you can ask questions. But also, you can tweet at CodeCoffeeYVR, and Steve over there will be watching that if you have any questions, and I will read them out, probably, along with the other questions. Also, you can tweet at me, keyword new, either or. So take it away, Clemens.
Okay, so before we start this talk, a quick round of audience participation. Who here is a web developer or does web development type of things? Oh, that's quite a lot of people. And who here uses Python in any capacity? Okay. Who here uses Python and does web development? And I guess you're all very happy with this choice, right? So Python, for example, is, in my opinion, a great stack for doing web development. You have very high-level language, really expressive, super simple to do everything, and usually there's one way of doing things, right? Zen of Python, there should be one way to do things. And kind of similar in the web stack. That is until you actually have to deploy the application that you wrote to production. And then there's this Cambric explosion of complexity and of choices. So for example, do you use Apache or Nginx? Which of the 1,500,000 UWSGI servers do you need? And do you need to introduce an async layer so that you don't block your workers? And which of the frameworks do you want to use? And frankly, for me, this is just too much and a bit too complicated. Hi, I'm Clemens. I'm an open source developer at Microsoft in the DX team, Developer Experience, and we work on interesting projects with third-party partners, generalize the solutions, and then release them as open source. And I do quite a lot of Python, and I've had these headaches because of this previous diagram one too many times. And so I asked myself, well, there must be a better way to do this, right? Follow the Zen of Python. And that's what I'd like to talk about tonight, a simpler way of doing web development and simple web services in Python using a stack that not many people know about called using Authbind and Sonic. So first of all, what is Sanic? Sanic is a relatively new web framework in Python. It has a super simple API, like if anyone's ever used Flask, this will be very familiar to you. You just create an app, you have your functions that do your business logic, you decorate them to route them to some URL, and then you wrap your response in some response type like JSON in this example. The main difference between Sanic and other stacks is that it comes with a server, and so does Django, so does Flask, they would say. But at the same time, the server in Sanic is actually production ready because it's async. It uses the new Python 3.5 async features, and it has built-in support for forking itself over multiple cores, unlike the Flask and Django servers. So that means if you run Sanic, all of that complexity already goes away because it just gets replaced by Sanic. Now, the second part of a web service is that usually you want it to be available over HTTP on port 80, so that people don't have to do something crazy like call your thing with a URL and then colon 8080. Problem is, for port 80, we need privileges to bind to that. Well, we could run Sanic as a privileged application and just bind straight to port 80, but security folks would probably shout at us. So we need some way of getting port 80, the request there, forwarded to port 8080 where our app runs. And normally people would do Nginx or Apache for that, but we don't want to introduce that because we want things to be simple. And so there's this little tool called Authbind. It's a Debian software, but it'll run on most Linux systems. And it's super simple to set up. It's just those 4 commands. And it lets you configure your Linux environment so that non-privileged applications can bind to port 80. And it does this with some magic that's too complicated for me. But suffice to say that it basically replaces, swaps out the bind call, and goes around this privileged users only for port 80. And so then with Authbind, you cut out that top level of complexity. And then all that you're left with are 2 things. One of them is 4 lines of code to set up. The other one is 2 lines of code for a framework, and that's it. You're live, you're in production. Now, Sanic's motto is gotta go fast. And for me, there are 2 parts of going fast in software. One of them is going fast for code speed, but the more important one actually is developer experience and how fast is it to get something out to your users. And this is where I'd like to talk a little bit about a story. 3 weeks ago, I was in Tokyo working with a customer, and this customer, they wanted to do some machine learning. The problem is, and we used Azure Machine Learning Studio, which makes a lot of things very simple. Problem is, it was in Tokyo, so their data is all in Japanese, and they had a lot of Japanese text. And Japanese is not a very common language, so we don't have first-class support for that in Machine Learning Studio. There are a lot of NLP primitives in there, but they all expect a white-spaced limited stream of tokens, right? Like you would have in English, where each token is a word. So we need a way to turn a Japanese sequence of characters into a white-spaced delimited text, where each token, where each white-spaced delimited thing is a word. Fortunately, there are some people who do this kind of stuff for a living, researchers who build tools to do the segmentation, so we wanted to wrap that in a service and then call that from within Azure Machine Learning Studio. And then we went from idea to having a thing in production in less than an hour using this stack. It goes super simple to set up, then you just deploy it to your VM and you're done. Now let's talk about the other aspect of speed. Gotta go fast, this is performance. So I set up 4 quite standard Python stacks and a Sanic stack and compare them. So on the left here, we have your classical Flask, Gunicorn, and Nginx stack. Here you have a stack with Nginx and Tornado and Connection. If you don't know Connection, great framework if you like specs and OpenAPI. And then Django plus Apache and mod WSGI, which is also a very standard stack. And then I run a benchmark using this framework called Locust, where you can write your performance tests in Python, which is pretty cool. Check it out if you don't know it yet. And this is the results of the benchmark. We see that Sanic and Authbind, the super simple stack, is actually as fast as Nginx, Gunicorn, and Flask, which in my opinion is pretty amazing, because you could spend 3 minutes setting something up, and it's as fast as something that's super complicated to set up. And we're faster than Django. Some more details on this benchmark. We had 2 tasks in there. One of them is a network-based, network-bound task, where you go to a database, you fetch some data, you return it, and the other one was a more framework-based task, where you just serialize some data and send it back, just so that we cover a bit all the common operations that you would have in a normal web application. If you don't trust these benchmarks or whatever, they're all up on GitHub, all the setup scripts for the VM, so you can just deploy those. I used a quad-core machine for this on Azure, but you can use any machine really, and you'll have similar results. And if your favorite Python web development stack isn't in here, please fork it, make a pull request, and add it to the comparison. That would be great. That's all I have for tonight, and I'm happy to take any questions.
Thanks, Clemens. Before we start questions, I should mention these talks, the wine, the coffee, all brought to you by Sauce Labs. Sauce Labs is our sponsor, and Sauce Labs actually supports a fair number of community projects, so they're quite awesome that way. Also, Mobify helps us out by giving us their space for the evening, which is fantastic. Thank you. Okay, so now to question time. I see a hand over there. So Clemens, if you'd be good with that, like you could repeat the question and then we can record it because we are streaming live. Cool. Go ahead.
So whenever I try to use frameworks, I always, or most of the time, find I need like an ORM, something that generally comes with. Is there one that you tend to use with Sonic?
So the question is, normally when you do web development, you'll need an ORM at some point to go talk to your database, and Django comes batteries included with the Django ORM. What would we use here with Sonic? Well, to be honest, a lot of people don't like the Django ORM because it's kind of opinionated and it's not as good as SQL Alchemy, so just use SQL Alchemy. It works for Flask, right? Some really big websites run Flask in production, so you can just do the same thing here. So yeah, I'd use SQL Alchemy.
Awesome. Next question.
Yeah, kind of a follow-up. Has SQL Alchemy been updated to take advantage of async operations?
The question is, has SQL Alchemy been updated to take advantage of the async operations? To my knowledge, not yet, because the async stuff is still pretty new. So here in Sonic, the thing that you get for free is you just have def, async def your route, and then that will run asynchronously, but most of the code, unfortunately, inside of your function will still run synchronously.
Cool. Another question. I think we might cap it at 3, and this is the third one. We'll cap it at 2. All right. Thank you, Clemens. Another round of applause for Clemens, please. Cool. I'm going to welcome our next speaker up, Anish. Where are you? Hey. There you go. You're almost all set up. Before or while Anish sets up, I will also mention, because we have 2 talks and maybe people need to go to the bathroom, but the bathrooms are that way, straight down the hall. There's a woodenish looking door that has the exit sign right over it. The bathroom is through that corridor and on the other side. But the thing to note is this will let you get in to the bathrooms themselves. So you should know that code. That's the code. The bathrooms are password protected, so you use that code. Take a photo before you go, because then you'll have to come back and it'll probably be quite uncomfortable. Yeah, so Anish, welcome.
Okay, so sorry. Did I? Okay, I thought that was going to be really tiny. Can everyone hear me fine? Yeah. Okay. Cool. I'm gonna do some live demo stuff, so I can't hold the mic probably at the same time. Okay. So, oh, is it not working anymore? Hello. Yeah, it is. Okay. All right. All right. So I'm Anish from Stat Search Analytics. I'm the director of technology there, and today I'm going to be talking about developing using Docker and ECS. So just going over what are the things you'll be actually discussing. So firstly, I'll be talking a bit about what we do at Stat. This is just to sort of lay the context for why use Docker and why you're using Docker and ECS. But then it's a bit of a demo sort of thing using Docker, how we can develop locally using that. After that, I will talk a bit about Elastic Container Service. What the hell is that, and why am I using it with Docker? And finally, what are the next steps for the project? So let's get started. At Stat, what we do is we crawl search engines. We crawl Google, Yahoo, and Bing. We crawl them on a very big scale. And here I've just searched the keyword Code and Coffee Vancouver on Google, and it's giving me, some results, a Twitter page, a GitHub page, some images there. So we also parse all of these results out. When I was doing a practice run of this at the office, everyone was like, why don't you just show them what we do? So that's what I'm going to do now. This is kind of what happens, right? So we search a search term. I'm searching DuckDuckGo here. We don't support DuckDuckGo because it's just not that popular. Yeah, we do this on Google, Yahoo, and Bing. And here you see I've searched a keyword, and there is this HTML page. And so we'll parse out all these results and classify them. Oh, I'm going to close that. Go back to the presentation. Oh, it's really tiny here. 1 second. All right. So so like I was saying, we do it at a very big scale. We have about 15 million daily searches that we're doing across the search engines. It's running like what we call a distributed system, like a whole bunch of different steps. We produce a lot of data as a result, 750 gigs of compressed HTML, and then so on and so forth. You know, there's some JSON data, lots and lots of rows of SQL, all going into various databases. The problem specifically that we're going to be talking about today is well, Docker and ECS, right? So our thing with setting up this whole crawl on our local machines, we call it the crawl, right? The whole spider parsing and then classifying all the result types is done on our local machines through a bunch of manual steps. All the systems, a whole lot of code, a whole lot of different componentry. Right now, all manual steps is like 4 pages long. There is differences in dev and prod. You know, the major differences really don't bug us that much. It's those minor differences that really sort of like, okay, a package is different on our OS X machine. We are an OS X, Mac OS X shop. And then we sort of deploy it onto our EC2 instance in AWS, and all of a sudden, it's not working for some reason. It affects developer productivity, makes everyone sort of angry with their lives, you know. And then the other part about it is we use a lot of AWS services, right? So apart from the EC2 server that we run all this code on, we are sort of using a lot of S3. S3 is this file storage service that Amazon offers. You can put in lots of any kinds of files on it. And so we use that to store the HTML. When you want to do that all locally, it's kind of hard, right, to do it, because you don't, unless you have a facility to like really mock that out, you're just testing against production servers. So today specifically, like, you know, we have a lot of different components, like I was saying, the spider doing the spidering, the parser parsing the HTML out, and then a few other components as well. I'll be talking about the Docker in the context of the spider. So the spider's job is really simple, just like in the demo example I was showing. Given a particular keyword, the keyword in that case was code in Coffee Vancouver. You search it on a search engine, you get an HTML, and then you have to save that HTML. So the components, I've sort of talked about a bit of this already. What we use in production to do it is EC2 that runs a headless crawl, just like the ones you guys just saw, and S3 where the file gets saved to. Now we want, with like all the problems I was talking to you guys about, a simple way to be like, okay, here is my environment on dev. You know, I have something similar to my EC2 machine. I have something similar to my S3. It's all working perfectly. I'm confident about it, and I can easily deploy it to production. That's where the whole Docker thing comes in. Now, there's lots of different ways of doing this. You don't have to choose Docker, but that's the one I'll be focusing on in this talk. Docker is this whole concept, right? Like, I mean, people try to explain it in different ways. I won't be, and there is obviously a lot of discussion to go into the details about the low-level workings of it. I'll be going very high level here. What I'll be sort of touching on is a few of the different important commands as well that you use with Docker. So essentially what you have, let's start from the far right. What you have is a registry, right? You have a registry of images. These images, the icons there's an Ubuntu icon, there's an Nginx icon. There's basically software installed on these images. And like, you know, for example, when you download Ubuntu from their website, you get an ISO. That's kind of like an image. A Docker image is slightly different, but that's the idea there. Then, so the first thing you do is pull, right? You pull this image from the registry. After you've pulled it, you got in your image, you can run the image on a container. So in this diagram here, you see Docker host. The Docker host on your local machine will be something like Vagrant, a virtual machine, on Amazon, for example, it'll be like EC2, like an EC2 server. Inside the host is where, when you do the Docker run command, is where the container is actually running. Now, the build command comes into play when you want to change an image. For example, if I just wanted to run an Ubuntu image or in a container, I would just do the pull and the run. But I wanted to add my own code to it, I would do that, and I would build a new image, and then I would run that on a container, which runs on a virtual machine. So that's like the key concepts around Docker. If you haven't tried it out, this is just a helpful link at the bottom here. I found when I was getting started with it, it was really helpful. They have good examples. They walk you through all the different concepts. So check it out if you're getting into Docker. Why use it for Spider as a service? Right? And so the whole idea for the Spider is actually saying making it into a service. We want to think of the Spider as two distinct components. One is the headless browser that is actually getting the HTML, and the other one is the one that's saving the HTML. And so, like, when I was trying to use Docker and trying to figure out how do we take this concept of a Spider that we have running on our local machines and move it into Docker, I sort of thought about doing it in these steps, right? It's sort of like, you don't go to the final goal of having EC2 and S3, everything working on your local machine. You sort of start small and you build up from there. So the first thing was, let's just run a normal crawl on the local machine, just like the ones I already showed you guys, right, and get that HTML. Next, let's just Dockerize the crawl component. What I mean by the crawl component is let's forget about where the HTML is stored. Let's just store the HTML locally and just Dockerize the portion that's actually doing this headless browsing crawl. And then after that, for the local machine, what would be really nice for us to have is a mock AWS S3 service. Like the APIs and the actual working of it from a developer standpoint is the same. Obviously, internally, it's different than the S3. But if we can have that on a local machine, we can kind of confidently say that, hey, it's working for me on this mock thing, and I can probably take it and put it into production. Finally, one of the things, like I was saying, that affects developer productivity and annoys people is like there is a lot of steps, right? 4 pages long steps right now for us to set everything up. So you want an easy way to configure it and prepare this Docker image for Elastic Container Service. What I have here, actually, if you guys are interested in this topic and kind of trying to see how all this stuff is built up, I'll just go to the actual GitHub page. I have this GitHub repo. Oops, that's the wrong thing. So yeah, so this is it. And here, I'll do a brief walkthrough of the repo itself, right? So what we have here is I just tried to describe what the objectives were and what to do to get most out of this repo. After that, I've outlined all the steps. The steps here are just the steps we were just talking about. And you can click through on each one of these steps, and there's a couple of things here. The first thing it has for that particular step, the final resulting code that comes out of it. And so you can just run that and it tells you how to run it. But if you like to actually go about it and do it yourself, when I was working through it, I created this dev log for each of the steps that outline how you can do it, right? And it also goes through a set of problems. The step 1 doesn't really have many problems, but if you go to like 2, 3, and 4, it outlines all the different problems that I faced. So going back to the presentation here. All right, yeah, so let's run some code. So step 1 was, I just showed you guys, it was running a headless crawl, right? And that was fairly simple. Step 2, I'm not going to, for the sake of time, I'm not going to show this step because all it is really is it's doing the same crawl, but you can pass the keyword as a parameter. So instead of hard coding Code and Coffee Vancouver, you can pass a keyword through the CLI. I'll go straight to step 3. And actually, what I'll do here is go to the repo, because it describes step 3 and in more detail here. So in step 3 is where we're actually Dockerizing this whole thing. in order to Dockerize it, the first thing that I did was, I have this headless crawl running. What I'm using for it is a JavaScript library called Nightmare.js. So the first thing I did was search on dockerhub.com to see if there is a Docker image for Nightmare, right? And then I found one, and the reasons I thought it looked good, because the instructions made sense to me. There was the GitHub repo that was linked to it, so I could see exactly what are the different software packages that were being installed. And also, the versioning of software and stuff was kind of reasonable, not the best, but I thought it was good enough. Next, what you do, like I was saying earlier, is you pull the image, and then you create your Docker file. Your Docker file basically says, this is the image I want to use, and it outlines the usage instructions. Well, this is basically the usage instructions. Here, the only thing to point out is you might find the /workspace thing kind of strange. The original creator of the image, the way he had designed it is that all your code is run from that /workspace directory. So what that add dot to workspace is doing is that it's not copying over, removing all the code from your local machine into the workspace directory so that it can be run. Yarn install there is just the Yarn package manager installs all the libraries. And that's it, right? So after I've gotten the repo, I've made my code changes, I can build it, and I can run it. The only thing the other key thing, actually the only other key thing that I want to point out here is this particular command right there. So let me actually run it, and it'll probably become more clear then. So I've already pulled the image. Now I can go ahead and I can build it, right? So I pulled it. My code is already in there. I'm going to build it. And so it'll just do its stuff. It's adding all my code from the local repo into workspace. It's running yarn install. It's installing all the packages, and that's good. Now, to actually run this, I can just run it with the docker run command. Right? I can just go docker run, and which I can just do. I can just go docker run and just provide in the name of the container, ECS S3 scraper, right? Index.js is the piece of code inside the Docker container, and just search anything I want. Now it's doing its stuff. The Nightmare crawler is actually running on the Docker container, not on the local machine, right? And it finishes successfully. It's cool, but what happens is since we are saving the file at this stage onto the local machine, we don't have any access to it because it's gone onto the Docker container. And in the repo, I sort of explained that in more detail. To be able to actually access it from the local file system, we got to mount our local file system onto the Docker container. And that's what this step is essentially doing. So it's saying that -v command is a command that you use to do that. And it's kind of annoying a bit because it depends on absolute paths. So you got to put in a whole absolute path in there. But once you do that and you search it, and I'm going to actually change it so you guys don't think I'm cheating, I'll put in something else. I'll put in the name of the company I work at. So now when it's running, it's going to do the same thing, except it's going to save. If I go ls, you'll see that it has created getstat.html with the time right now on my local machine. So that's what the mounting thing is doing with the -v option. It's mapping our local file system onto the Docker file system. So this is already cool. The last thing I want to show you guys is the stuff with step 4 here in terms of a demo. All of this stuff, one of the important things was not to have a lot of steps in order to run this on a local environment. I want to make it as simple as possible. This is where something like Docker Compose comes into play. And so thinking of Docker Compose, you can think about it in sort of this way. So what the whole idea is that I need 2 different containers, right? I need like a fake S3 and I need a Nightmare. The ghost there is representing the Nightmare, and the other thing is actually the Amazon S3 logo. Now, in order to set both those containers up, you kind of want them to be working together as a service, right? And this is where Docker Compose comes into play. You pull both those containers from the registry, but it sort of hooks them together into a particular application that runs together as a service. And to show what I mean in terms of a code and how simple it is, this is where I got, I did the same thing that I did with Nightmare. I went to Docker, hub.docker.com, looked for fake S3. I found this particular Docker image. I thought it was pretty cool because the library that it uses has Node.js bindings. It's actually well supported. It's well used, and it's been Dockerized into a Docker container. Now, it runs locally on my machine just by running this command. So I pull the image, I run it on my local machine. And that's all cool and stuff. With Compose, what you can actually do is you can hook them together quite easily. So this is all my different steps that I went through. I had issues and stuff with the IP and the networking. And finally, when I discovered Compose, I was like, this is really cool. This is really cool because I'm creating this YAML file, which is describing what the application looks like. It's describing two different services there. The first one being the scraper that I'm building from, I'm building an image from my local or my current working directory. The volumes thing, I'm just defining directly inside the YAML itself. And it's exactly the same as we were talking before. Mount your local to the workspace directory. The second one means don't mount the node modules thing because I want my Docker container to actually compile all the libraries, the Yarn libraries that I need. I don't want it to be sent over from my local machine. The next two bits there are what's really interesting. You can link different services, right? So I'm linking the scraper there to the S3. The S3 is just the fake S3 Docker image that I've obtained. And it's saying that the scraper now is linked to S3, and it depends on S3. So these two services work together, and that's how, if one isn't working, the other one will not run. And doing that simplifies things a lot, having this YAML file in this way, because now the steps become just two steps. I don't need to do all the things about mounting the volumes. I don't need to worry about building the images individually either. I just do a Docker Compose build that builds the stuff, and Docker Compose run. And it's really simple and straightforward. So I can show you guys this. I do a build. It's building my scraper. It won't build the other one because the other one has just been pulled, and all it has to do is run it. And after that, I can go ahead and actually run the scraper and search a particular keyword there. All right, let's just search Vancouver. I do that. And it's going to do the same thing here, except now instead of putting it into my local directory, it's going to put it into this fake S3 that we have installed using from a Docker image. The fake S3, if you guys go through the docs and stuff, you'll see on GitHub that it just runs on a particular port on your local host, and this is it. It's running. After the code completes execution, I have some previous previous crawl that I did. But let's go into the S3 directory. It's very simple and similar interface to Amazon S3, in fact. So it has nothing here. If this finishes successfully, well, 5 demos, right? It timed out, apparently. Yeah, so I'll leave it running again, but the idea is that once it finishes, you will see the file pop up on the fake S3. And really, we can take this now. The last step is essentially just setting up our environment variables so that we can take the code and put it into ECS without having to do much changes. And that's where this piece of thing is really cool, that because we had a link established between our scraper and our S3, we can just access the Amazon endpoint using this particular URL. It's just using the name to figure out the IP address, and works that way. And here I've described all the different things that I went through to actually discover that and get that working. So if this thing has completed, now it's timing out again. It will eventually run. But yeah, so that's the stuff. Now we have, at this point, our Docker image, 2 of them, in fact. One of them is running our fake S3. One of them is running our code, and it's putting the HTML that's grabbed from DuckDuckGo into fake S3. Very similar to what we want to do in production. So it solved these issues that we had, right? I mean, the manual setup on the local machine, we can use Docker Compose with a simple YAML file, and you don't have to do much, just 2 steps to run it. The differences in dev and prod, well, that is solved kind of by using the whole Docker thing. And the last part about using, how to test against services, you can use you can mock AWS services really easily using Docker. I'll just briefly touch on Elastic Container Service here, because all it is really is after you have everything running on your local machine, in terms of the Docker images, the setup that we have, you can take those containers and you can push them onto Amazon's ECS service. ECS service is essentially running those Docker containers on the EC2 instances. It's self-managed and it's very easy to scale. So this is just one of the interfaces. You go in, create a repo. I created a repo called Headless Spider. You can click the push commands and push your particular image. In my case, the image was the ECS S3 scraper that I can just push. After you do that, the steps are you define a task. The different definition of a task is essentially, in our case, you provided the file you want to run and the keyword. So you'll say run index.js, run it for that particular keyword. The cluster is provisioning how many instances, what kind of instances you need. And then you can test the task just individually on the cluster, or you can create a service for it. So now at this point, I have, I initially had a local version of our crawl running using Nightmare. I took that and then I combined it, I put it into Docker first. Then I took the fake S3. I was able to mimic what AWS has in production in terms of EC2 and S3. And finally, I'm able to sort of deploy it into ECS. From here, there's a long ways for us. We just started working on this project. This is basically a POC. As I was saying, our crawl is kind of a huge thing, 50 million keywords every day. What we have in terms of Docker and ECS is it works for one keyword or a few keywords that you can program manually, right? AWS Batch builds on top of ECS, as in it provides, along with the whole container and the compute environment system, it provides you a queue system so that you can run, we can run this 15 million jobs through into a queue, and it's all managed in terms of using ECS and Docker containers. And so after we are successful in doing our ECS stuff, we want to try out Batch and see how that goes. If you have any questions about the ECS S3 scraper, you can contact me at that email address. Check out the GitHub repo. It describes in much more detail all the steps that I went through. And if you encounter any issues, just open an issue, and I'll try to respond to those on the GitHub repo or through email. Thank you.
Thanks, Anish. Actually, this kind of just reminds me, we know how to name them, don't we? Nightmare. Things like that. Programmers, we know how to name them. On the other side of the thing, there's another thing I came across. What was it? Fantasyland. So you got, on one side, you got Nightmare. On the other side, you got Fantasyland. It's kind of interesting. But yeah, so we went a little bit over time with that one, so there won't be question time for the second speech, but feel free to reach out directly to Anish. I'm sure he'll be happy to answer your questions. This brings us to the next part of the evening, which is the third part technically, is where we mingle. You have the run of the space, so all this. There is wine, there is coffee, and I think there are also snacks, but it's there, right? Yeah, there are also snacks. But before I let you go, I should say talks. We are taking talks for the next time, which is going to be, I believe, maybe not next month, maybe in August. It might be in August. But our talks go like we have technical, so design or programming or experiences. So actually one of my most favorite talks was how to build and retain inclusive and diverse teams. That was a very good talk, by the way. It's rather difficult to do the second part of it. So yeah, that was great. That was from last year. We should bring them back again. But yeah, so if you have a talk that you find interested you because it was your experience or it was a tool you used, reach out to one of us through Twitter or by like old-fashioned way, like talk to us. We're here today in this space. But yeah, thank you very much for coming to Code and Coffee. Enjoy the rest of your evening.